Thanks for this. Welcome, everybody. I'm Richard Dasher. I direct the U.S. Asia Technology Management Center at Stanford University. I'm also a board director of Keizai Silicon Valley. And so I'm very happy to welcome you today to this event that's produced by Keizai Silicon Valley. We're happy to be the event sponsor from Stanford and host this webinar. So I would like to turn the microphone over as soon as possible to the people who know what's going on, especially our moderator for the day, Mr. Phil Keys. Phil, the program's yours.
Okay, hello everybody, and welcome to today's event, Electrification of Air Transportation. As Dr. Dasher mentioned, this event is being put on by Keizai Society with the sponsorship of Stanford U.S. Asia Technology Management Center. And welcome. And before we get started, first of all, I'd like to introduce our very important sponsors for Keizai Silicon Valley. And give me a minute here. So, first of all, our platinum sponsor is the Miner Foundation. And we have our gold sponsors, Pegasus Technology Ventures, Wilson Sonsini, and Procopio. Silver sponsors, ZL Tech and Tazan International. Bronze sponsors are Ito-En, NEDO, TMI Associates, Jetro, Provider Consulting, Teroka Legal Counsel, and of course, last but certainly not least, the Stanford U.S. Asia Technology Management Center. And just as a short reminder, our next event is going to be June 30th, 2021 Pacific time. And it's called Being Innovative in the With Corona Era. And hold on a minute. Okay, sorry about that. And again, so the event is called the Electrification of Air Transportation. And we're going to be looking at topics around the electrification of air transportation from both a Japanese and a US perspective. And so first of all, please let me introduce our panelists. We have, first of all, we have Fred Borda, who is the CEO, co-founder and CEO of Aerial Innovation. And please wave when I mention your name. And Mr. Shigeru Takano, Executive Advisor, ANA Strategic Research Institute. And Mr. Yasutada Tanabe, Senior Researcher and Leader of High-Speed Rotorcraft Research at JAXA. And myself, I'm Phil Keys with Intertrust Technologies. So the program is going to start, I'm going to start out with a short presentation for myself, soon be followed by presentations from each of the panelists. We will be doing Q&A, and appreciate it. We will be appreciate it if everyone could enter your questions into the chat function and then we'll be reading them from there. So with further ado, let's just go straight on in. So some of you of a certain age might remember a time then when I remember this song called Mellow Yellow by Donovan. And if you listen, if you may remember, at one point, one of the refrains goes, electrical banana is going to be the sudden craze. Electrical banana is bound to be the very next phase. Now, I'm sure at the time, for whatever reason, the singer was just kind of struck by the term electrical banana as something interesting and fantastic that he was going to introduce into the song. But I think many of you agree, including myself, that if it was only just a few years ago, if you'd heard the term electric aircraft, it would just be just as much a fantastic phrase as electrical banana. However, going to 2021, it does look that we are indeed on our way to having electrical aircraft being the very next phase. Much as we have seen, as we've seen with EVs, and by the way, when I say EVs, I mean electric ground transportation vehicles. The electric vehicle, we're seeing a lot that electric vehicles EVs are going to revolutionize and help us transition to a cleaner economy from ground transportation. There's a lot of attention also being paid to electric aircraft. In particular, electric transportation, air transportation is getting a lot of attention for its carbon footprint. As of 2018, it was estimated that air transportation made up a total 2.4% of all global emissions, and that's directly contributed to global emissions. And the estimate is if the air transportation sector continued its growth, this could triple by 2050. So with the focus on how are we going to clean up the air transportation sector, electric aircraft are getting much attention as a good short-term step towards cleaning up this sector of our economy. And I think as you've seen, as you may have noticed, here in Silicon Valley, we're seeing a lot of startups that are going into this market. And I think this is being driven a lot in many ways by much of the same investor interest that we've seen in EVs. I mean, after all, when in January of this year, Tesla was estimated, their market cap was estimated to be, was greater than the next 5 automotive OEMs combined. It doesn't take much imagination to think what electric aircraft could potentially do to companies like Boeing. So, of course, we're not only seeing not just startups, but established companies also like Rolls-Royce and Airbus getting into the market as well. And not only are we seeing potential OEMs, but we're also seeing interest from potential buyers like UPS, Finnair is mentioned here, and regulators are also beginning to move in direction to help encourage electric aircraft. And also, we're also thinking about the infrastructure as well. As this one article says, why not turn airports into giant solar farms? So for today's event, we're going to be exploring these topics. And one thing I want also to be clear about in terms of definitions is when I mention electric aircraft, we're going to be talking about aircraft that can carry passengers or a significant amount of cargo. So we won't be covering the smaller drones that some of you might be familiar with. And that's it for me. And we'll pass it on over to Mr. Borda.
Thank you, Phil. And thank you to Keizai Silicon Valley and the Stanford US Asia Technology Management Center for this opportunity to help everyone to understand a little bit about what's going on with electrification of air transport. Can you see my slides? Okay. Great. So my name is Fred Borda. I'm one of the principals of Aerial Innovation. We're a strategy consulting firm based here in Silicon Valley. We provide strategic advisory services to large enterprises, mostly in Japan, and focused on this advanced air mobility or new air mobility. Some people call it UAM. There's a little distinction in those terms, but we'll gloss over that for now. And then we also work in the commercial drone space as well, or commercial UAS. So we typically advise companies that are not traditionally in aviation how they can provide value in, there's this new wave of innovation coming in new aviation, and how our clients can build enterprise scale businesses. Our principals both have been doing analysis and advisory in the technology sector for several decades. Based on a few decades in the technology sector, we see new air mobility as kind of the intersection of technologies that have been maturing for some time, but it's really exciting to see them applied to a new sector. So I'm going to divide my quick introductory remarks here into kind of three categories. First, when will the future get here? A little bit about the ground infrastructure for electric aircraft, and then touch on the business models that electric aircraft enable. So first, what are we talking about here? So I guess to start off, electric aircraft are coming. There's no question about it. So the future looks something like this illustration that I shamelessly borrowed from NASA. So just to set the stage, advanced air mobility, or AAM, covers everything that you see here. And to just kind of highlight it real quickly, in addition to the small package delivery and cargo delivery, which is envisioned to be done by unmanned aircraft, so what some people call drones. In addition to that, and we're not really going to talk about that today, there are manned electric vertical takeoff and landing aircraft, or eVTOL aircraft. These are aircraft with pilots carrying passengers within cities, and that's what's being called UAM, or urban air mobility. So you can think of these kind of like helicopters, but with some important improvements. And then there are also eCTOL, which is electric conventional takeoff and landing aircraft. So aircraft that take off and land at airports. And these are envisioned for transport between cities. So then in addition to what you don't see on here, so it's not part of the AAM vision, is work that's proceeding on electrification of larger aircraft. So like, the kinds of jet aircraft that we all, are familiar with to fly to Tokyo, for example. These are not typically included in the AAM vision, but it's an important parallel area. So everything I've just mentioned is a vision that includes, that focuses on electric aircraft. Okay, so that's the future I'm talking about. So when does it get here? When can we have our future? So the answer to that is very soon, and also not for a while. So the very soon part is, these advanced air mobility eVTOL aircraft here in this first segment, 2 to 5 seat battery electric aircraft. The first of these are probably going to be certified by the FAA in 2 to 3 years from now. They're in certification right now. Some of them are. And then commercial service, we can probably expect to see 2024 or 2025. And these are companies like Joby, Archer, Beta, Wisk, and there are a number of others. Then there's also work going on to certify small propeller aircraft, which, so 5 to 19 seat aircraft. Some of them are retrofits of existing airframes. Some of them are all new aircraft. So the retrofits include companies like Magnix and Ampere. The new designs include companies like Eviation. They have an aircraft called the Alice. Ampere is also in there, Bi Aerospace, Magnus. And then finally, here's a third category that is hydrogen fuel cells to power motors on a, this is a retrofit to existing regional jets. And here I'm referring specifically to a company called Universal Hydrogen, which is working on this kind of a concept. Super interesting stuff that they're doing. So that's the very soon. So these things, we should expect to see these in the next couple of years as well. The not so soon, or it's going to take a while part, is the large transport jet-like aircraft. So you can probably expect those to see those aircraft electric and in operation sometime after 2035. In the 2040s is a time frame that we hear a lot. And the reason for that is that you can see here, when you go from a couple of 100 kilowatt sized electric machine or motor to a megawatt plus, and then the total power on the aircraft is 10 megawatts plus, 25 megawatts in some cases, you're talking about a big jump in the development that has to happen to get us from the left side of this all the way over to the 2035, 2040 timeframe. Okay, so I'm not going to focus too much on the aircraft themselves. We have some really fantastic experts on the aircraft on our panel today. I'm going to talk more about the ground infrastructure. So there are a few aspects that present challenges and, of course, some business opportunities for electric aviation. So vertiport design, weather information, traffic management, charging. I'll hit each of these in turn. So vertiport design. So can't we just land and take off with these new aircraft from existing heliports? The answer is yes, maybe for some, but probably not at scale. So if we unpack that a little bit, existing heliports are designed for one basic configuration, the single rotor helicopter, right? It's got one rotor, well, so anyway, the eVTOL aircraft, first of all, they have wings. Many of them have wings so that they can use lift when they're in their cruise phase of their flight and be much more power efficient. Most heliports are not sized for something that has wings, even if they're somewhat modest wings, like we see on the eVTOL aircraft. Another thing to take into consideration is approach paths. So current design of heliports and the airspace around them assumes typically an 8-to-1 approach slope of, that's you can see it illustrated here in with the blue. That's the slope at which the helicopter approaches, comes into, and lands or departs from the heliport. Well, the eVTOL aircraft may need to minimize their time in hover. And so they may want to make a much more abrupt, more of a, not a right angle, but closer to a right angle in their approach to the heliport, or to what will come to be called vertiports. Other areas that are of particular concern, the passenger operations, right? What are you going to do about passenger operations at a heliport that was designed for very low traffic volume, very small number of passengers? If you try to optimize a business model around, transporting lots of passengers, you're going to need boarding areas, you're going to need baggage handling, you're going to need security screening, all the, security for the air side versus ground side, all the stuff that happens at a high volume airport, you would need to do at a small vertiport. And then a place for the crew, places for maintenance and repair, if it's not a separate, facility, and fire protection. Fire protection is very different from, between liquid fuels and electric batteries. And then finally, the environment that these are placed in is probably going to be different. So it'll be urban for urban air mobility. It'll be on tops of buildings, and there may be integration with parking and ground transportation to get some multimodal efficiency there. So another area of ground infrastructure is weather information. Right now, today, we don't have really good sensing down at of what weather people call the planetary boundary layer. So the under 1,000 feet that surrounds the Earth. Because we don't have a dense network of sensors, we can, I don't want to say guess, but we can make educated guesses about what's going to be happening with the wind at a particular spot at a particular time. But if we don't have a dense sensing network, it's not very precise. Smaller aircraft are more susceptible to winds, especially think about urban canyons, right? You've got small aircraft landing in urban areas. That urban wind canyon is going to be a big deal. And it's not only a safety issue, but there's also operational efficiency. If operators have better weather information, they can make better decisions about routing their aircraft, changing the routes at certain times of the day, changing their operations for the day. But we're seeing some relief here. Some help is on the way. There are new aviation weather paradigms emerging. So new sensors that are not the typical aviation, extremely expensive, very finicky aviation weather sensors, but instead are more something closer to an IoT sensor, or are maybe something in between. So wind LiDAR is an example, 3D visualization of wind. And then using the data techniques that we use in other domains, applying statistical techniques, statistical methods to the data, and being able to still rely on that data. New data providers are emerging, and they're building new decision support tools based on these new paradigms. So an example is True Weather Solutions, the company that I borrowed the image from here as an illustration. I don't know why there's a box on this slide, but the next area is traffic management. So today in air traffic management is pilots talking to air traffic controllers, exchanging information and maintaining safe separation between the aircraft by voice. Well, that's probably not going to, there just aren't enough air traffic controllers for thousands and thousands of vehicles to, in city centers. So AAM is envisioned to fly mostly in uncontrolled airspace, so it doesn't require air traffic control. That's under typically about 1,500 feet. And then organize themselves in corridors, or what's being called now an operating environment. And the operators of the aircraft, think like the airlines, can share flight routes between themselves, flight routes within the corridors, share the information between themselves programmatically with automated systems, and maintain separation between the aircraft that way. So, and this, by the way, is so this comes from a concept called UTM, or UAS traffic management. UAS means drones. It's developed at NASA and is being widely embraced around the world. And this will eventually make its way into both UAM, urban air mobility, as well as sort of all air traffic control at some point. And then the last thing is on ground infrastructure is charging. So there are going to be huge impacts on the electrical grid, not only the loads, but also fast charging. And the equipment itself is, if you've ever been to a Tesla supercharger, there's a little building you may or may not have noticed that houses all of the conversion equipment. The equivalent of that is going to have to go on the vertiport someplace. So up on the top of a building, that's a challenge that needs to be solved. I'll also mention hydrogen. Again, hydrogen is is an excellent energy source. There are some technology challenges, right? Storage technologies, ground infrastructure. I mentioned earlier a company called Universal Hydrogen. This is their concept for kind of creating a kind of like Nespresso pods for aircraft with hydrogen. It's a very clever idea, and I encourage you to look into that more. Hi. I don't know why this is appearing like this, and I'm not sure I can fix it. This is a slide that illustrates business models. This is a slide that illustrates a business model. So just to talk about the business models for UAM a little bit. So these electric aircraft make some new business models possible. So they don't need a runway. So they're kind of like a helicopter, but they're fast, they're quiet, they're expected to have much lower operating costs than conventional helicopters. So you can combine these with some other innovations that we've seen recently and get powerful demand aggregation, bringing lots of riders together to ride on these vehicles. So some of those innovations are things like ride pooling, like Uber Pool, and multimodal coordination. So coordinating between the part of the slide that you can see, which is, you order with your app, you order a rideshare ride that comes to your doorstep. You take that ride for 10 minutes to the vertiport. You get on the eVTOL aircraft, 7-minute ride, and then a 5-minute walk to your final destination, all for, excuse me, much less than a helicopter would cost, and a tremendous amount less time than it would take to drive yourself or ride on an Uber Pool or Lyft. There's now, let's see if this fixes itself with the next slide. Okay, so another opportunity that emerges with electric aircraft is different scenarios for business models in aviation. So right now in aviation, all of the, if you look at these rows here as the value chain in aviation, a lot of it's broken up. This is an oversimplification, but a lot of it's broken up between different parties in the value chain. Well, the new players like Joby and Lilium and some others, they see opportunities to vertically integrate. So to be this guy over here on the right that vertically integrates and captures efficiencies like the lower maintenance and operating costs for themselves. So that's I think we usually call that disruption. And then the slide that image is supposed to appear on in the orientation that it's supposed to appear. And that is to get away from AAM a little bit. Just one last comment on something called thin haul or short haul thin haul, which is using conventional takeoff and landing aircraft. So electric fixed wing aircraft using runways. And some of the other innovations that we've seen in urban air mobility or advanced air mobility, and applying these to those aircraft. So it creates an opportunity to use smaller existing airports, so for example, here in the Bay Area, San Carlos Airport, there are providers in this space today, although they're not using electric aircraft quite yet. You can book a seat from San Carlos to, so for example, up to Reno or Tahoe. And in fact, the original research on this kind of thin haul transport came out of the same NASA research project that eventually spawned UAM, or the urban air mobility that we're seeing today. So, so some of the players here are folks like Cape Air, Surf Air, and we can expect to see more of this as as electrification of these aircraft make their business case even better. So that's sort of a quick overview. I'll turn it back over to Phil, and thank you very much.
Okay. Thank you very much. Interesting presentation. Just noticed a little while ago that there was a company called Harbor Aircraft, which operates seaplanes up in Canada, which is now said that they're going to be going full electric. And that'll be a fun one to fly on at some point. Okay, so next up, I'd like to turn it over to Tanabe-san of JAXA. Tanabe-san?
Okay, thank you. So this, I'm Yasuta Tanabe. I'm working for JAXA. I want to start with some background talk about myself and my research on the eVTOLs. And I want to make an introduction of Eclair. That's a consortium in JAXA. My personal experience, before I joined JAXA 15 years ago, I was working for Kawada Industries for another 15 years. In that, during my stay in Kawada Industries, I've been engaged in develop the unmanned helicopter. We convert the manned helicopter Schweitzer 300C into an unmanned version and flight unmanned. I think in that era, it's very pioneering work. Finally, this work was differenced by the VTUAV, by the US Navy. Right now they are converted much bigger helicopters into unmanned version and use the other observation platforms. Also, we developed an unmanned version based on Schweitzer 300A. We developed the actuators and the flight controls, and we autonomously fly this aircraft. Also, I engaged in development of the unmanned small miniature air vehicle. It's fixed wing, but we fly it automatically. This is a project together with Hitachi. It's Hitachi Kawada micro area vehicle. Finally, it's used by the Japanese defense. SAT UAV, they use it at this. So finally, the production version was 5 kilograms and carry infra camera. And I also engage in some motor driver and attitude estimation for the humanoid robots. First, we made prototypes for the University of Tokyo of this kind, and then we got engaged into a national project, HRP project, humanoid robot project, together with the AIST, Sansoken. This robot is designed to work together with human. We made a lot of demonstration for that. And finally, the Kawada industry has set up Kawada Robotics. If you are interested, you can check their website. Right now they are selling a two-hand robot, and they can stand on the production line and using two hands to assembly very complicated productions. Here the previous premier Abe was visiting this factory with this next stage robot. When I joined JAXA in 2006, my main work is shown in this slide. Firstly, my major work is actually doing the analysis for the rotary wings. We can handle the very complicated helicopter shapes using very sophisticated numerical methods, and analysis the elastic deformation and the vibrations of the blade together with the aerodynamics. Finally, we can prediction the noise at any place. And also, right now, my major work is developing a high-speed rotorcraft. This one is a compound helicopter. During the flight, we using propellers for propulsion. Then the helicopter can keep level in altitude and has a very low drag. So it can achieve, our goal is to achieve twice the speed of the conventional helicopter. Also, using some government fund, I have engaged to involved to develop some variable pitch controlled drones. This one is a test bed, and also we try to install a shroud to improve the hovering performance. But it comes up that when you have a shroud, it will be very sensitive to the wind. But we can find some applications, for example, inside the tunnel or something for the investigation, for the observation. And this is some detailed show of the analysis flows. We call it the R-Flow 3D analysis toolchain. Right now, there are over 10 universities who has interest in the rotorcraft research using our software. And also we are licensed to the companies and some research institutes. So we are just work like a basic background for the Japanese research for the rotorcraft. This is some example of the analysis. And this is the example for the vibration analysis for the natural frequencies. You can avoid a resonation at some certain operational speed. This is prediction of the noise on ground. We are also carry out some measurement in the JAXA's wind tunnel. And this one is a concept of the high-speed combat helicopter, and this one for the variable pitch controlled multi-rotor drones. It's funded by the Japanese government, the impact program, and right now we are using the Kakenhi, the grounding aid for scientific research, for doing this kind of research. And with that, we can analyze very complicated flow fields around the multiple rotors. Here is shown one example when the multiple rotor is hovering near the ground. You can see the flow on the ground when the intersection cross the rotor centers. It works like a general single rotor. The downwash go down and flow around the wall closely, around the ground closely, but around the section inside in between the rotors. I mean, there's no rotor axis axial here. You can see it's quite different from the single rotor. The high-speed region come to quite a higher altitude. So you can feel the wind when you get down nearby that. But in this phase angle, if you stay in this position, you can only feel the wind on your feet. So the ground downwash is quite different compared to the general conventional helicopter. And also I'm engaged in some analysis of the noise. We're using the model. It's based on the SkyDrive design, but exactly we didn't have their parameters. So the prediction here is just assumed based on some assumed technical data. They have three blades, turning coaxial blades, faucet. From that, you can see the noise pattern on the ground is become very complicated. There's some higher level region, but somewhere will be lower, because the sound from each rotor is just like a sound source. When the other rotor rotates in the nearby frequency, they cause some harmonization between the noise. So we need to be very careful about the noise patterns. If so, there's some, maybe we can find some good design point to get lower noise by tuning the rotating phase and something, and considering the difference between the rotors. Okay, here I want to make some introduction about what we are doing in Japan, in JAXA, about the aircraft electrification. The following slides are provided by Dr. Akira Nishizawa. He is the leader for this program in JAXA. I want to make the presentation instead of him. The ECLAIR is stand for the Electrification Challenge Consortium for aircraft consortium. We call ECLAIR. The overview is is present in this slide. It's established in 2018. In 2018, and we have cooperations with the Japanese major companies. You can see a lot of company name is here, the IGI, the JAXA, Kawasaki, and Mitsubishi, Hitachi, and some other famous companies, and observer from the government side to get involved in this consortium. The aeronautical industries are doing the aircraft design and development, and for JAXA, we are doing the electrified propulsion system research, and we can carry out the aerodynamics and the mechanics control research for these systems, and we can carry out ground and flight tests using JAXA's existing experimental aircraft. And there are a lot of electrical industry, raw material and parts industries get involved in this. I think they are new player in the aviation industry. They are doing the electrification elements about the battery, power and the motors, and other peripheral technologies. And JAXA alone is difficult to tackle all the issues of electrification. So we got a number of domestic companies with high potential with the electrification technologies. The overview, the vision for this ECLAIR is in 2020s, just as Fred said in his presentation, and the small one for example, for the eVTOL will become up in the 2020s, and I think the small aircraft stand for also cover the eVTOLs, and for more electric aircraft, we gradually are going to use some compound hybrid system to have more electrical things in the airliner aircraft, and gradually we can apply the application of the electrification technologies to commercial aircraft. The narrow body, this small size, fixed wings, and generally in 2040s, they already reduce the fuel consumption of the aircraft with electrification as a core technology up to wide body, and finally the ideal case is reach the ideal goal of electrification in the 2050s. It's quite 30 years later away, but this is JAXA's vision. I think the roadmap is shown here to gradually just as I said, we're going to doing the ground test, flight test for these systems. So in the early stage of the hybrid mode, the battery is support the electric motor generated by the jet fuel by the engine. So the major driver, the propulsion is also provided by the turbine itself. But gradually, we can have a generator and drive other engine, have a main engine generating electricity power and then provide it to other motor. Sorry, to other propulsion systems using by the motor driven by motors. So finally, they have the ideal system is we have a generator only that does not directly provide propulsions, and we have a distributed propulsion systems driven by motors. So a lot of things, a lot of technical challenges to reduce the fuel consumptions. So many things about the high efficiency motor, high power density motor, and other generator, inverter, and other electrical components. So the important technical issues. First thing is is come to war things is high power density, compatibility of safety in battery and high energy density and high efficiency, assurance of safety and reliability is common to all things. And the others important technology in high altitude environment is for the big airliner aircraft is withstanding the electrical discharge and the radiation and heat and power management and control. And other for the under low altitude operations, the fault resistance is important, and the low noise is also important issues. So the detailed roadmap is shown here. We are going to go from the more electric aircraft systems, development them using the electrical hybrid systems. Finally, apply them using the combined system, using liquid hydrogen, and finally apply these technologies to the wide body, to the world, the larger airliners. So the technology development group in the Eclair, there are two areas. One is a cooperative area. So the members exchange information inside the consortium and make it public. We will the aircraft electrification common basis and the business model of a small electric aircraft and the consideration of a ground infrastructure. And so the JAXA and the KU University are big players there. And there are also several competitive different group. DENSO leading the development of high power electric density electric motor, adopting advanced magnetic circuit technology. And the Merco is a Mitsubishi electric company, are leading the high altitude environment adaptive power conversion and distribution system. And JAXA also have some group working on the Rolls-Royce propeller for eVTOL applications. So as a summary for the Eclair, the electrification technology for aircraft is the key to achieve dramatic reduction of CO2 emission from passenger aircraft and innovative changes to everyday transportation service for small aircraft. Through open innovation by strengthening cooperation with different sectors, aim for expanding of the aviation industry by applying the electrification technology, which Japan has a technological advantage to the aviation field. JAXA, under the Preparation of Electrification Challenge for Aircraft Consortium, promotes the research and development of the technology that is essential to the common system components of small and passenger aircrafts, and that greatly contributes to fuel consumption reduction. We shall continue expanding the results from above for electrification of the components of small aircraft in the short to mid-term plan, and for electrification of the passenger aircraft in the long-term plan. That's all for my introduction. Thank you.
Okay, thank you, Tanabe-san. One thing I'd like to let everybody know is that we plan on having these slides up after the event available at the Keizai Silicon Valley website. So if you'd like to get copies there, it should be up. Please visit the website a few days after the event. And Tanabe-san, just a quick question. You were talking about noise as part of your research, and I'm sure that everybody who's heard a drone understands that they can be a bit noisy in terms of a rotor. Are you looking also at reducing fuel consumption?
Of course. The high efficiency design is a key technology for us. We are doing some optimal design technology to design the propeller shapes and something. Actually, for myself, we provide some profiles for JAXA's other program also. Also, we are using for the high speed aircraft, rotorcraft. I'm developing the key technology there is the optimal rotor design for the high atmosphere ratio flight. That's quite different for conventional helicopter. So this we are doing cooperation with Kawasaki Heavy Industries for such kind of development. Thank you for your comments.
Okay, great. Thank you. And I guess next, last but not least, we'll go to Takano-san from ANA. Takano-san, I think you're muted.
I'm so sorry. I started over again, and I'm trying to introduce what ANA or Nippon Airways is thinking about to introduce the advanced air mobility in Japan. And I will be starting with the introduction of myself. My name is Shiro Takano, and I am the executive advisor to the ANA Strategic Research Institute just for a year and a half. And before that, I used to be working for the Japanese government, mainly working for the aviation safety and security, as well as the international aspect of the civil aviation. And actually, during my tenure as the Director General for the safety and security, I was involved in the establishment of the public-private council for the air mobility revolution in Japan, which tried to introduce the advanced air mobility in Japan. Next, I will try to introduce the what ANA is like, and I hope everyone knows about Oriental Airways as airline, and brief history about the ANA. Actually, it started as the Nippon helicopter company, which deal with the helicopter, vertical takeoff and landing aircraft at the start, and now we are dealing with the eVTOL, electric vertical takeoff and landing aircraft, and so there are some familiarity. And the other thing I wish to touch upon is we are not only dealing with the large airplane, we have just launched the drone air mobility project in 2016, which is now I'm working for. And also we have established the Avatar Inc., as well as we are trying to make things in with the Virgin Orbit to launch the spacecraft. So we are very, innovative-minded company. And in that context, we are trying to launch the advanced air mobility services in Japan. So next, I try to touch upon briefly about the background. And probably you have listened to the Mr. Borda about what is AAM and what it looks like. And yeah, actually, it started with the concept of the urban air mobility proposed in 2016 by Uber. It's a kind of very sensational document for us, and help us understand what the future air mobility will look like. And so, as an operator, what's the benefit of the electric vertical takeoff and landing aircraft could be? As it already introduced, it has the complexity and the best part comparing with the conventional VTOL helicopter. And actually, helicopter is very beautiful craft, but they require the, let's say, very huge rotors, main rotor and tail rotor, which require the very complicated mechanism like gears to connect engine and rotors, shaft to connect engines and tail rotors, and so on. And also, single main rotor or single dual main rotors provide all the lift for the aircraft, which means there are very important single point of failure. But the multi-rotor eVTOL does not have no single point of failure. That means we can easily achieve the higher level of safety by introduction of the eVTOL comparing with the helicopter. Also, less complexity and less parts means the lower cost for the maintenance and lower cost for the operation as well. Also, probably with the introduction of the automation technologies, the eVTOL will be much easier to fly than helicopters. And also the noise and CO2 emissions. It's the very environmental friendly craft to fly. So that's the benefit, we believe, of the eVTOL, and which will be, how do I say, easier for the society to accept. even with the even in the heart of the big city like Tokyo. And actually, there was a history of the helicopter operation connecting the airport and downtown of big city like New York. I remember that there is the ad in the 80s which said that you can fly from Pan Am building in the downtown New York or Manhattan to the JFK in 10-20 minutes with the cost of blah, blah, blah. But that kind of services could not continue long because of the safety problem or because of the noise problem and so on. So it will be very necessary, very important for the to achieve the higher safety and more environment friendly operation if we are going to fly into the big city. And this is the, let's say, urban air mobility maturity level defined by the NASA, which explained how the advanced air mobility will evolve. And it's a very practical as well as challenging steps forward. And but it approaches the what we do is based on the currently available technologies and the frameworks. We will be starting with the electrical VTOL aircraft with the multiple rotors with the pilot on board. And we start with the low frequencies and a limited number of routes with the current regulatory and current ATM framework with the small amount of the adjustment to them. But the final goal is the, let's say, high density and high complexity operation, which will accommodate the thousands of simultaneous operations in the megacity area. And so to achieve that, there are many technological challenges, many regulatory challenges, and many infrastructure challenges. But it's a kind of process that while technology is developed, we are preparing for the installation of the new technologies in society. And so it's a very, how would I say, new and innovative approach in the civil aviation, because previously or currently, what we are doing is the introduction of very proven technology into the aircraft and air traffic management. But we are planning to introduce the very challenging technological development and very innovative framework changes in the future. Okay, next slide. So, and let me go through the what ANA is thinking about the development of the air mobility in Japan. First, advanced air mobility is expected to be a very big, how would I say, that will have a very big market. Even in Japan, there is one forecast that the market for the ANA will be $25 billion, billion yen in Japan in 2040. That's a big number. And we are trying to start our involvement in the AMM from the airport shuttle service. Airport is a very big base for ANA, and it's natural for us to start the service with airport shuttle. And it will be, or we are planning to start the airport shuttle services in Kansai area in the occasion of the Osaka Expo 2025. Like Kansai Airport to the site of the Expo carrying passengers. And then we are going to expand our services to Tokyo, Nagoya, and Okinawa. Then we will be entering into the route which is not relevant to the airport, like intercity or intercity transport services, and then on-demand air taxi and so on. But the speed of progress will be very fast, and we are expecting to have the on-demand air taxi services soon after the 2030. And it's a potential network for the whole region. I referred to as the airport shuttle. And for Kansai area, Expo 2025, we are trying to start the Kansai airport, Kobe airport, to the site of the Expo and connect them with the Osaka downtown transport. Then similar thing will be happening in the Nagoya, Tokyo, and Okinawa. And probably everyone is interested in what the Tokyo service will look like. And actually, we are trying to find out the potential vertiport place in Greater Tokyo area, like a Haneda, Narita, and Chiba Prefecture, Kanagawa Prefecture, and downtown Tokyo and the Tokyo area. And they are very promising in terms of the traffic demand. And this is the time frame for our work to be done. And we are now in the phase of preparatory work. And we are planning to launch the, let's say, familiarization services in 2024, and then go into the Osaka Expo to do the, let's say, commercial passenger services to some level of the scale. And then we will expand operational area and the more mature services. From the government side of the thing, there are big commitment by the Japanese government to introduce the advanced air mobility in Japan. There was a cabinet decision made in 2018 to do something like to launch the public-private company. Also, those cabinet decisions referred to the year 2023 as the starting point for the eVTOL commercial services. As well, they refer to the 2025 passenger services in Osaka Expo in 2025. And so there is a big commitment made by the Japanese government for the early introduction of the urban air mobility or advanced air mobility in Japan. And so in year 2018, Public-Private Council for the Air Mobility Revolution was established, and they released the action plan for the roadmap for the advanced air mobility, which is like this. And it refers to the, how do I say, plan of the introduction of the air mobility in Japan, and also what government should do regarding the introduction of the new legal framework for the regulatory framework for the to accommodate the new type of the operation and new type of vehicles, as well as the what kind of technological development is necessary. And in the course of the discussion in the Public-Private Council, there are specific use case dealt with by the council or proposed by the stakeholders in the private sector and dealt with by the council. And those are the 2023 start to initial operation to 2025 start commercialization of transportation at the occasion of the Osaka Expo, as I told you. And from 2026 onward, expand transportation service to other areas and also medical and emergency services. And so on. So there are, let's say, many stakeholders who are interested in the introduction of AAM in Japan, and the government are trying to materialize those interests. Recent work of the Public-Private Council. Actually, there are working groups to deal with the specific tasks like the certification, pilot licensing, and flight operations, and so on. And each working group have identified issues to be addressed under the current framework, and including regulations and procedures which include ATM. And from this year, they are continue to think about how those issues can be addressed and come up with the result, which could be in time for the initial services of the AM in Japan in 2023. The other thing I wish to mention is the Osaka Expo. There are master plan released by the Osaka Expo Committee, which is released in December last year. It's already incorporated the vertiport for the eVTOL services. So they are ready to accept the AM traffic in year 2025. Also, there are local governments which are with interest in the introduction of the AM in their region, like Osaka, Fukushima, Tokyo, and Mie, and others. And so it's a very good foundation for the social acceptance of the AM in Japan. And now barriers and challenges. And in the short term, to introduce airport shuttle services, there are several barriers and challenges going through necessary regulatory changes and the regulatory requirement, certification, licensing, and air operator certificate, and so on. And also, we need to secure the vertiport. Especially, it is important to have the flexible access to the congested airports like Kansai and Haneda. And also, we need access to existing or new heliport in big cities like Osaka and Tokyo. And the other thing is, it should be safe and reliable. Reliability is very important for the passenger going to and from airport. If the flight is cancelled by the bad weather, there are which cause the it will cause a very big inconvenience for the air traveler. And so operation in the bad weather is very important part of the short-term challenge. Also, public acceptance and scalability will be key issues for the initial services. In the long term, to achieve the goal of the high density, high complexity, fully automated autonomous operations, there are need for the updated regulatory framework in parallel with the technological development. Also, there should be an innovative concept in ATM, which was partly briefly introduced by Fred-san. And also, it should be safe and reliable as well. And the new challenge will be the security. There will be a extensive use of the network technologies if we are going to have the fully automated and autonomous operation. And the cybersecurity will be a key. And the other thing is if we are going to introduce a pilotless operation, is it okay for the passengers, and the security of the operation should be achieved by some means. So the security challenges and public acceptance challenges for the fully automated flight. That's all for now. Thank you very much.
Okay, Takano-san, thank you very much for your presentation. I think we'd like to move on to Q&A. And again, please, if anyone has some questions, please feel free to place them in the chat function. And I'd just like to start off with one question. I'll bring in one of the questions into this as well. Is that how do you see development of electric aircraft, the differences between Japan and the US, as well as cooperation? So for example, are NASA and JAXA cooperating in this area?
Oh, yes. I can answer the question. In between JAXA and NASA, we have an annual high-level meeting between the management level, and we have a lot of ongoing cooperations between JAXA and NASA. For example, for the high-speed supersonic aircraft design, development, and something else. And there's a lot of area common between NASA and JAXA, but I'm not for the specific electrification field. I'm not sure. I don't think there's an ongoing cooperation right now, but we are always exchanging information. So hopefully, maybe we'll have some specific development program. I think we will join JAXA, NASA, and others to do the things. Did I answer the question?
Sure. Anybody else? In terms of maybe differences or areas that maybe Japan might have some strength in, and areas that the US might in this field?
So all across electric aircraft?
Sure.
Is that what you're looking at?
Mm-hmm.
Yeah, there are a number of areas where Japanese companies can bring and are bringing strength to this. There are, so a lot of these aircraft rely on light and strong composite materials. That's for a long time, that's been a strength of Japanese companies. Some of the first eVTOL, electric vertical takeoff and landing aircraft that are in certification right now use composites from a Japanese company, Toray. There are, another example is Denso is working with Honeywell on avionics and related systems for eVTOL aircraft. So they have a specific cooperation there where they're, I think, sort of bringing together best of breed solutions for the eVTOL manufacturers to integrate the aircraft. And we've seen over the last couple of years, we've seen a number of Japanese companies express interest in this in the supply chain. There aren't really as many full aircraft manufacturers in Japan. Japan's aircraft industry was significantly curtailed after the war, but there are a lot of component technologies. And there's probably another important thing to mention is that so traditional aviation today, so the Boeings and the Airbuses of the world, they only manufacture a few hundred or 1,000 aircraft a year. the volumes of manufacturing that we're looking at in this sector for again, we're talking about the AAM aircraft, it could potentially be thousands or even tens of thousands of aircraft. And so for that, you really can't, Boeing and Airbus, when they're building those big jetliners, it's basically a hand-built airplane. And you really need to shift towards mass production for that. And of course, particularly Japanese automobile companies, are very good with mass manufacturing. So, so there's been a lot of interest from Japanese car companies, and we're starting to see some cooperation there as well.
Thanks. Hey, there was a question that came up, especially around lightning of aircraft. It's obviously something that's always been important, but particularly around electric aircraft. The question was specific around windows. Are anybody familiar with any activity towards creating even lighter windows?
Unfortunately, I don't. That's not a specific component area that I know a lot about.
Okay, great. And then I guess there's another question. It's kind of ties into something that we've talked about. Is we talk about essentially community acceptance of electric aircraft. What's important? What's needed for that? And there was one question here that really talks about particularly that eVTOL will be important to rural communities and remote communities to help them improve transportation between those communities and more urban communities. So, in general, what are the types of things that are needed towards community acceptance of electric aircraft, and particularly around rural areas?
Let me say that the question is very good one, and actually, rural or remote area could enjoy the benefit of eVTOL because the eVTOL is small, just a 4-passenger per aircraft, and it's cheap, and the price of transportation will be very affordable comparing with the current mode of transportation at first. So it's a good fit for the essential transportation services for the remote and rural area. And the other thing is the rural or remote area is less sensitive about noise. It may cause. And so it's a good fit for the services produced by the eVTOL. And so I believe that there will be even in Japan or even in the United States, operators which would provide the essential services with the more convenient, which is more convenient than the conventional transportation services. Operator will be providing such services in the rural or remote area. Does that answer the question?
Sure. Any other particular anything that comes to mind regarding just the acceptance by the community as and consumers of electric aircraft? That I mean, quite a lot, but just some top of mind issues.
And actually, let me say this way: if we think about the bigger cities, public acceptance will be very challenging because there are a lot of people, a lot of opinions, a lot of people feeling the aircraft flying over their head differently, in a different way.
Yes.
And so there are diversity of views, and some of them opposing, some of them in favor. That kind of thing. But I don't expect the services for the rural or local community will not be a very, frequent one, like a 5-minute interval or things like that. So the annoyance made by the eVTOL traffic will not be such big. So it will not be a big problem as is expected to be in the big city.
Okay.
One other comment I would make about community acceptance is that the industry seems to realize that this is a very important thing, and in fact there are efforts underway to kind of begin to lay the foundations for community acceptance. So there's an organization here in the U.S. called CAMI, the Community Air Mobility Initiative. And CAMI is looking at working with local governments and communities to first try and educate them and help them understand what is this that folks are talking about, and to really understand the benefits. And one of the things the industry is trying to do is to get out there and help people to understand, and Takano-san alluded to this, help people understand what the benefits are. And if they can see the benefits, then that can in many cases outweigh the costs or the drawbacks. So that's begun already.
Okay.
Okay, if, maybe I can have some comment from
Sure.
the technical side.
Mm-hmm.
And I think for the community acceptance, one big concern is about the safety, and another one is about the noise. And for the safety side, I think we can prove that gradually by test case in some remote area from the islands, in some sparse populated area. So I think time can serve, and generally I think the multi-rotor type eVTOLs have more safety features than general helicopters, because the system is basically naturally it's a redundancy. Even one system failed, you can still keep going and can run safely. So I think gradually we can prove that. I think the new technology always, firstly, people are doubt about that. But when you prove that, and when you show them the benefits, then people can come on for that. And generally, we can learn the limit of the operation. For example, we can avoid the bad weather operations, and to what wind speed we need to stop the operation, something like that. And for the noise things, I think it's a compromise between the performance of the efficiency of and the noise acceptance. Because if you want to have no noise, the most important factor is the reduce of the rotating speed by cut the, for the helicopter, generally the tip speed, rotor tip speed is about 200 meters per second. But for the general drones operating nearby, generally the tip speed is about 100. It is half about the tip speed. Then the noise is reduced by 30 decibel. So that's some linear relationship between the tip speed and the decibel noise. So I think with the tip speed about 100, if you want to make it bigger, you need a larger wing area, larger radius of the rotor, and the aircraft tends to be heavier, so the efficiency is reduced. But anyhow, I think finally we can find some compromise between that. We need a complete new design concept from away from the conventional helicopter design rules. That's my comment.
Oh, thank you. So we're getting past 6:30, which was the time limit of this event. With the audience's forbearance, I will just ask one more question, and I think we will call it for an evening or a morning, I guess, for our people in Japan. But Takano-san, I think I'll pass this question to you about certification for commercial aviation, and particularly since electric aircraft do bring in many different types of novel designs. both in Japan and the US, how what's the work? How is work proceeding on the regulatory side towards certification of aircraft?
Actually, it already mentioned in the Mr. Board about the type certification of the several model is underway by the FAA, and basically Japan is following that path. We are now thinking about what kind of the technical standard will be applied to the eVTOL aircraft, as well as the what kind of the standard shall be applied to the pilot operating the aircraft. And but the basic idea is there shall be a type certification and the airworthiness certification for the aircraft, and there should be a license for the pilot operating the aircraft. And so basic framework is the same and with the different set of the standard. The other thing is there are air operator certificates for the operators, which require the maintenance manuals and the operation manuals and the safety manuals and so on. And if those have to be also adjusted to the operation of eVTOL. And that kind of work is already underway in the US and as well as in Japan. Thank you.
Okay, thank you. So we've gone over the time. I really appreciate everybody's patience. And what I believe again, as I mentioned, the panelists will be sharing their slides. We'll be sharing them from the Keizai website. I believe that the panelists have included their email addresses, so please feel free to get in contact directly with them. And also, I'd be remiss I have to remind everybody that our next event will be on June 30th, around how to continue innovation, particularly from a legal framework, around the time of being, especially that we have to live with COVID for a while longer. Anyways, I want to thank everybody. I would appreciate, let's give a virtual round of applause to our panelists. And I really appreciate all the work that they put in this, and particularly for the audience. I appreciate your attention, and we look forward to seeing you at the next event. And hopefully soon we'll be able to do this in person again. Thank you, everybody.